Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
So, variation is also proportion. You know now.
Yeah.
Okay, there are different types of variation. You have inverse variation, joint variation, and partial variation. Sorry, they actually, we can say four. There's direct variation, inverse variation, joint variation, and partial variation. All right?
Yeah.
Okay, so let me just review them like this. Let's see these questions that I already have here so that we don't waste time. You know what this is about. If y varies directly as x squared and y is 8 when x is 2, find y when x is 1. You know, it's the usual one, very easy, isn't it?
Yeah.
It says y varies directly as x squared. This is a sign we use. So what do you normally do next? You introduce k, the constant of variation, isn't it?
Yeah.
So y is equal to kx squared. This symbol is used for the variation, this thing that looks like this, you know. Alright, so y equal to kx squared. All you need to do is find the value of k so that you can substitute. So what is k? Sometimes they will ask to even find an equation. So find k. K is what? Y over x squared, am I right?
Yeah.
Okay. So you can use any of the values given. When y is 8, x is 2. When y is 8, x is 2 to find k. So that will be what? 8 over, when y is 8, x is 2. So 8 over 2 squared, which is 4. Or 8 over 4. You're still with me?
Yeah, I am.
Which is 2. So k is 2. And that is what you just substitute into that formula. By the way, the real equation, because sometimes you may be asked to write an equation connecting y and k. Since you found k to be equal to 2, you can rewrite the equation as, that's you rewrite this equation. I'm going to put it in purple color, because sometimes you may be asked to write an equation connecting y and x. Now that you have found the value of k, what will be the equation now? Y equal to what?
Y equals to 2 times x squared.
2x squared. You know, so that's what you can always use. This is the new equation now. The 2 is from k, substituting k with 2 from here, you know. Alright, so they say find y when x is 1. So this one is very easy. When x is 1, you just substitute. Y will be equal to 1 squared, which is 2. And then that's cool.
Yeah, it is.
That is for direct variation. Direct. Of course, inverse variation. In fact, direct variation is when one increases, the other increases at the same rate. You know that now?
Yeah.
You know what I mean? In science, the graph will look like this. For direct variation, if you are plotting a graph of A against B, if A varies directly as B, what kind of graph will it produce? A straight line graph that passes through the origin, isn't it?
True.
If A varies directly as B, you know what I mean? You know, it will produce a straight line graph that passes through the origin, because when B increases, A increases at the same rate. If B doubles, A doubles. If B quadruples, A quadruples. If B is halved, A is halved. If B trebles, A trebles. Whatever B is multiplied with, A is also multiplied with it. So and the way the graph will show it is it is a positive correlation. It's sloping upwards. The graph line slopes upward and it passes through the origin. Alright, now for inverse variation, you know that if says if W is inversely proportional to U and W is 6, when U is 6, find W. Of course, inverse variation is just W is inversely proportional, so we write W inversely proportional. Inversely proportional is 1 over U, you know that. Am I right?
Yeah, you are.
Okay, so W is inversely proportional to U, W is 1 over U. Then you also introduce the concept of proportionality and change that to, so it now becomes W equal to K over U. Am I right? Once you introduce the concept of proportionality, you change that to equality. Okay, you can also make K, so the formula K is equal to WU. And then you substitute into the equations. What's W? 6. What is U? 2. So what will be K? 12, isn't it?
Yeah.
6 times 2. Now it says find W. First of all, write the equation. I always say write the equation. We write the equation. So what will be the equation connecting both? That will be W equal to K is now 12. 12 over U, isn't it? You know what I mean? Because we found K. All of that is from here, giving rise to this. This is the equation concerning. So find W when U is 6. So that is easy enough. W when U is 6. So that's just W is equal to U is 6. 12 over 6. Because U is 6, which is 2. Alright, now for joint variation. Joint, it will have two different kind of variation, one directly, one inversely. So you just write both. Then it says, look at this question. Can you read it out for joint variation?
Y varies directly as x and inversely as the square of z. And when x equals y equals to 6 and z equals to 4, find y when find x when y equals to 10, when x equals to 10, when y equals to 10 and z equals to 8.
Alright, so joint, because two variations are involved, one inversely, one directly, or something. Y varies directly as x and inversely as something. So you just write it out like that. Can we go? So y varies directly as x and inversely as z. Do you get it?
Yeah.
Directly on the same line up, as you can see, inversely down. Okay, so you introduce your k, so y is equal to kx over z. Do you understand? Make k solve the formula. It's easier. There was a method you were talking about. This is faster. K is equal to yz over x. Am I right?
Yeah.
Just find k so that we write the equation, the formula for it. Let's find k. So k will be equal to what? Let's use the values given. When x is 32, y is 6, and z is 4. So, oh no, sorry, it says square root of, inversely as a square of z. See, this is actually square of z. Do you understand?
Yeah.
Y varies directly as x and inversely as the square of z. Square of z is actually square of z. Square of z, not just z. It's directly as x, but inversely as the square of z. I hope we have corrected all that. Alright, so let's go. Let's find k. K will be equal to 6 times what? Square of z. 6 times 4 squared.
6 times 6
4 squared over x
6.
over 32. Are we good?
Yeah.
Just substituting. So what's k? That's 16 times 6 is 64. No, what's 16 times 6? Quickly get it.
That would be 64. I'm
No. 16 times
that's
6.
16 times 4. 16 times 6.
64 plus 32.
Maybe 96.
96. So 96 over 32. Do you have a calculator? Let's just get that. 96.
96 divided by 32.
What does that give?
That would be 3.
3. So k is 3. So let's write the equation that connects all of them. Remember, you are just writing the equation from here, but this time around you are replacing it with k. So y is equal to what? What's k? 3x over z squared. Do you understand?
Yes.
So this is the equation. So what did they say we should find now? Find, read out this last part.
Find
X
x when 10
when y is 10 and z is 3. So y is 10. So we just substitute. Y is 10 is equal to 3x. We don't know what x is over. Sorry. Yeah, the 3 is for k, you know. I'm just substituting into this green stuff. When y is 10, 3x, x is unknown, z is 3, so 3 squared is 9, isn't it?
Yeah.
That's 3 squared. Just substituting into all this. So you can easily find x now. So 90 is equal to 3x. That means x is what? 90 over 3, isn't it?
Yes.
Which is 30. Am I right?
Yes, you are.
Okay, let's see. Let's do this one. You need to tell me, by the way, when we're talking about inverse variation, you know the way the graph of inverse variation works. If you have
Nobody.
how
Oh.
the graph of inverse proportionality, if A is inversely proportional to B, you know how the graph will look?
This will be like,
You slope downward, isn't it?
yes.
With a negative slope. Alright, I hope you're good.
Yeah.
Alright, so let's see this one. Read this. Read this question. Read where I am. This is it. Let's look at
X varies jointly. X varies jointly and
as
x
y.
as y and the square of z. When x is 15, y is 6 and z is 2. Find z when x is 18 and y is 9.
Okay, can we go ahead and do that? X varies jointly as y, is it not? That's directly as y.
Yeah.
And the square of z. Do you understand? This one not inversely, still directly square of z. Does it make sense?
Yes, it does.
X varies jointly as y and square of z. So x, both of them are direct variations in two forms. So x directly proportional to y and also directly proportional to z squared. Okay, let's just introduce k. So x is equal to k y z squared. Find z. Find k rather. K is equal to x over y z squared. You know what I'm doing?
Yeah.
Just make a sort of formula. Let's substitute into the questions given, the values given. When x is 15, y is 6, and z is 2. When x is 15, y is 6. You're getting it?
Yeah.
And z is 2, so 2 squared is 4. What 6 times 4?
2 times 4 is 8.
I hope I substituted properly. When x is 15, y
Um,
is 6.
yeah.
X is 15, y is 6, and z is 2 square of z. Okay, so what does that give? K will be what?
It's 5 over 8.
5 over 8. That's 15 over 32. Did you say 5 over 8? 15 over 24?
Yes, 5 over 8 when you get it
Okay, reducing to the lowest term. Divide both sides by 3. Okay, K is 5 over 8. Alright, so let's write the formula that connects all. So what will be the formula that connects everything? X to be equal to, we're just substituting it from here. You know what I mean? Then we replace K. So X is equal to what?
5 over.
Yeah. No. Just write the formula first. 5 over 8 for K.
Times y times z
Z squared. 5 over 8 y z squared. Okay, so now it says find z when x is 8. Find z when x is 18 and y is 9. So we just substitute. Can we go ahead?
Yeah.
When x is what?
That would be
18 equal to 5 over 8 times y is 9, isn't it?
Yeah.
Times z, or 9z. You could have just said 9z. Do you get that?
Yeah.
Alright, so we just solve the equation. That's all. Let's go ahead and solve the equation. This is times. So what will you give? 18 times 8 is what? Let's just solve the equation, no wasting of time.
Yeah.
So
that would be
9z will be equal to 18 times 8 divided by 5.
yes.
So z will be equal to 18 times 8 divided by 5 times 9.
Times 9, yes.
Things we cancel out. This will be 2. This will be 1. This will be 2. Am I right?
So, yeah. That would be 16 over 5.
16 over 5. Which is what? So z is equal to 16 over 5. Or 5, 3 whole number. 1 over 5. Am I right?
Yeah.
Or 3.2. Alright. Finally, this one, I've made it easier by writing out some things while you needed to wait for you. Partial variation. Read out the question. Let me see if you can see it. I had to circle some things, but it blocked out some other things. Read out this.
That would be
Yes.
given that y varies partly with the square root of x, partly with the first square of z.
With
Given
this.
that y equals to 11 when x equals to 9 and z equals to 2, and y equals to 23 when x equals to 25 and z equals to 4, find the value of x when y is 30 and z is 6.
Alright, so it's actually easier than you think. We call that partial variation. It varies partly with the square root of x and partly with the square of z. Partly and partly. That's how you differentiate it from joint variation. Partly, in fact, it varies separately with those other quantities. Look at it. Look at the way I wrote it here. It's not difficult. Y varies with the square root of x, right?
Yeah.
And of course it's plus. First of all, partly with the square root of x and partly with the square of z. That's what you're seeing here. All you need to do is just introduce the constant of proportionality. Partly with square root of x and partly with square of z. So that's just it. You know, I need you to see this. This is the important equation you will need for all of this. Both of them are partly, because the partly thing must appear in both for it to be a partial variation. That's the fourth one. Remember, we have direct, number one, direct variation, number two, inverse variation, number three, joint variation, and then this fourth one, partial variation, as the fourth one. So you will see partly in both anytime you have partial variation. Now differentiate it with joint variation. You will just see y varies directly as x and inversely as this. Did you see that?
Yeah.
Alright, and also this one, y varies jointly as this and that. But when it comes to partly, you'll be seeing partly as this, partly as that. Okay, so that's that. I'm just telling you, you write out the equation. The equation is y varies partly with square root of x. So you see square root of x, you introduce the constant of proportionality c for the first one, and partly with square of z. Also you have square of z, you know, you have square of z here, z squared. You also introduce the constant of another constant of proportionality, because there are two different constants of proportionalities in this case, k. ck, you can use any letters, you know. Is it making sense?
Yeah, it is.
Alright, you just substitute. So when y is 11, x is 9, and z is 12. So you substitute y 11, x 9, y z4, z2. You just substitute into all of that. So when y is 11, x is 9. So square root of 9 is 3. So that will now be 3c. You understand? And z is 2. So square of z is what? 4. So that will be 4k. You call that equation 1. And look at the second case. The first case is the one I put in blue. The second case in yellow, you use the values again. When y is 23, x is what? 25. So square root of 25 is 5. That's why you have 5c. And square of 4 is 16. That's why you have 16k. You know, so you have equations 1 and 2. You just solve the simultaneous equation. Find c and k. Do you understand?
Yeah.
And then substitute into the third case that they want now. What's the third case? Find the values of x when y is 30 and z is... The third case is the one I wrote in red. Is that clear? So first of all, you solve this simultaneous equation 1, equation 2, to find, what are you trying to obtain? C and k, isn't it?
Yes. Yeah.
You find c and k. So you just substitute it into this equation, into this general equation you already have. I circled in green. Though I usually circle it in purple, so I can maintain it in purple. So you just substitute into this general equation to get the other value they find. So find the values of x when y is 30 and z is 6. So after you have found c and k, substitute here to find all that. I think that should be easy.
True.
Alright, so whatever it is, whatever c you found times square root of x, giving square root of x, this case will be, okay, it's even the value of x we are looking for, and y is given as 30. So I would have started with 30. I would have written 30 equal to c times square root of x. You would have found c, then of course plus, you would have found k times 6 squared times 36, you know, and you just solve to get x. That should be easy enough, isn't it?
Yes, it is.
All right, so that's just it. Every other thing is done just following the same rules. All right.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.